In this video, I want to start looking at the mean absolute deviation, which is going to be the first way we look at defining how spread out or compact a data set is. The deviation of a data point is its distance from the mean. So if xi is my data point and x bar is my mean, so this is my data value, and this is the mean, this would be a deviation. And what I really want to look at here is the average distance from the mean. On average, how far are things away from the mean? So if I look at adding up all of these deviations, x1 minus the mean plus x2 minus the mean, etc., all the way up to xn minus the mean, this is going to be equal to 0. And we can see this by thinking about the mean as leveling out. As I level out, all of these are going to be equally balanced. If I had to remove some from x1, I had to add it to x2, and it's going to give me this kind of balancing effect. So this is always going to be equal to 0. So instead, for our mean absolute deviation, we're going to take the absolute value of these deviations. And I'm going to add them up. So this is the capital Greek letter sigma, and it means a sum. It means we're going to add up a bunch of things. And then we're going to divide by the number of things we have. So we're going to take the average absolute value of the deviations. So let's look at an example. So here I have a set of data values. The first step is to actually find the mean. So I need to start by adding these values up and then divide by the number of things there are. And there are 10 data points here. When I do this, I get 66 divided by 10, or 6.6. So this was our first step, to actually find the mean. The second step is then going to be to find the deviations. So I'm going to do data values minus the mean. 3 minus 6.6 is negative 3.6. 7 minus 6.6 is 0.4. 4 minus 6.6 is negative 2.6. 9 minus 6.6 is 2.4. 5 minus 6.6 is 1.6. 4 minus 6.6 is negative 2.6. 6 minus 6.6 is negative 0.6. 17 minus 6.6 is 10.4. 4 minus 6.6 is negative 2.6. And 7 minus 6.6 is 0.4. The third step, we need the absolute value of these deviations. So 3.6, 0.4, 2.6, 2.4, 1.6, 2.6, 0.6, 10.4, 2.6, and 0.4. Finally, we need the average of these deviations, so we need to add them up and divide by the number of things there are. Once we add up all of these deviations, the absolute values of the deviations, we divide by the number of things there are. We get 27.2 divided by 10, or 2.72. And the idea of this is a smaller mean absolute deviation means my data is more compact, whereas a bigger mean absolute deviation tells me my data is much more spread out.